Welcome back to Adam Tech Tips, and I'm going to show you this. So this is not very different from the previous tutorial, but as we switch planets, we can see that it has smooth transition from that gravity point to this gravity point. And even if we try to get stuck in the middle, we can because it supports multiple gravity points and we just average them out and get the middle point. And we got this smooth transition from a method using F Interp. We also optimized this a little bit in the previous tutorial. We use even tick that runs every frame. I made a macro called Delayed Gate, so it only fires a quarter of seconds if I set this to 0.25, or it can even execute only every second. We're going to only calculate this every quarter of second or any time that we want, not every frame. And this is running on Unreal 5.6. And I'm going to show you guys how to do it in Unreal 5.4. So let's go ahead and do it. First thing first, let's shake up the color because when we are on the planet, it's hard for us to see which are we on the planet if we are succeededly transitions or not, and can look a lot more pretty when we have materials. What I do in the BP planet gravity is adding apply material inside our construction script. So let's find where we create the mesh here, and then after set the relative scale 3D, drag this all out, set material like that, and this material, drag this out and hit promote variable, make it visible, so it's going to be instance editable. Let's go to the engine. I switch on material filter. We have this orange basic asset 01. I'm going to apply it here, and it's instantly changed into orange. Let's apply the green thing. And that is the first step to have our simple material editable slot in our BP Planet Gravity. Now, after we can set the color, the second step is actually just how do we create this delayed gate. This is actually a macro. I'm taking this chance to teach you guys about macro. So I'm going to create a new folder, call this a blueprint lib, directly from the create blueprint micro library, and check the actor, name this gravity micro library. And inside this micro library, our first new macro, let's call this delayed get like that. And we can have input and output. Let's make it an exact on both sides. Let's call this exact, and this is going to be the return point. Let's have a sequence before that. And let's search for a do once. Do once is no matter how many times it called from the exec, if the do one is not get reset, it's only going to fire once, and we are going to use this for our delay get. So let's call a delay, and from then we call the delay, and when it's completed, it reset. Drag our duration here, and our first macro library is done. And we can call this anywhere actually. So we are going back to our third person gravity, and let's just get this sideways, and rather than on every tick, let's call up that delayed gate. Just plug this in. Maybe let's call this on half a second, and if we test, we can see that it delayed. See? And our macro delayed get is successful, and let's continue. Our next step is actually smoothing from that delay. It still felt like a lag, and what I'm going to do is use what we called is a V Interp. You might know there's a Interp 2, but this is for float. If you search for a V Interp, we have this one for our vector. It's going to be a lot more easier with a timeline to blend out current and target vector, but we can use this instead. So what I'm going to do is just, this is going to be the new gravity, right? And before this, let's call up the previous gravity direction. So it's going to move from current to target, but this is only going to call once. and how to get this V interp to be called multiple times so it gradiently moving from this vector to this vector smoothly. Let's do another delay loop trick like our gravity micro library here. So let's go for a delay. And I think it's best to call a branch. Why we want a branch? Because after this set gravity direction, we get a delay. And let's call this delay a little bit small for starters. So it's very small. And we are going to compare if it's close enough or not. But let's use not equal. So what I'm checking here is we just going to check, hey, is this two value at least close or not? If it's close, we don't want to loop anymore. So if it's not close and it's true, let's just loop to our gravity direction like that. Let's do print string. So it's going to be changing and it's going to be stop changing. False goes through here and this is going to be a sequence. This is going to be on this delay. And we also want our camera pivot calculation after all of this. So let's drag this here and let's not call the sequence to the gravity calculation anymore. For the interp too, you can just hover. Let's not fill this with 0. I test a lot. The interp speed is best to be 2. And then the delta time is how fast we are actually changing the value. So this delay is going to be better, at least for me, to have the same value. So like if we are delaying a little bit about 0.01, once it called and then it's changing 0.01 second, it's going to update again and the V interp going to know how much should we change. I hope this makes sense to you. And let's just test it all out. And it's already smooth. It's already smooth. See? And if it's already same, we can see that it prints stop changing. So we're not rotating the gravity anymore. We totally stop changing gravity. But when we walk, we move around on our planet, it's changing the gravity again. This is going to be very useful if our planet is very big and there's not much gravity direction changing. It's going to stop changing and we're not going to have update the gravity so frequently. Let's see if we transition smoothly. Yes, we are transitioned smoothly. And looks like we fall out of our planet. Let's rotate our gravity to there again. And of course, looks like we can't. And the gravity is now stuck. And we also get some errors. If we call set gravity direction too frequently, it can spill out this error. Looks like it's like trying to access none. And I tried a bunch of things, but I found the solution that the only solution is to pull this out and make sure it's safe to set the gravity direction. And only then we set the gravity direction. We actually did something a little bit too risky here. After we overlap every actors and we get our actor tag at branch, and then if we has the tag, it's spat out too. But what happened is these overlapping actors and this for each loop is going to multiply. So if we have like 2 gravity points, yes, it fires only once from this, but it's going to fire doubles in this loop body. Let's actually pull this up and make a function actually. I also like to tidy these things up a little bit. So rather than dirtying up our event graph, so I already made this gravity graph. Let's just delete this. So I'm going to make a new graph, call it gravity graph, and let's make a custom event and call it update gravity like this. And on event graph, we can delete this and we call the update gravity and it's going to execute inside here. So of course, we can just Control X and move it here like that. And I'm going to pull this here. The second part Of course, I talked about this before. So rather than loop body, we execute every time. Let's just select all of this and then we right click and collapse it into a function. And let's call this average all gravity points like that. And the return value, let's call this gravity final direction. So rather than going on loop body, we're going to on complete, but we need to save and we need to calculate all of the gravity first. So after we log all of our overlapping actors, if it's true that it has planet gravity, let's call this gravity direction. So another benefit of using functions is we get local variables here. So we don't get too dirty all of our event graph, our main event graph, and it's all saved here. And rather than set, I actually want to add. So rather than just single thing, we are going to take an array like that, and we're going to get, and we're going to add to the array like that. If it's true, it adds to the gravity direction. And before we add, if we leave it like this, it's going to add a bunch of gravity points. And we don't want that. Let's just clear it every time we're going to log it. So clear like that. Let's tidy this up a little bit. And we go on complete. But let's calculate this first. At a reroute node, I actually want to make a branch because if the gravity direction only have one, so length is going to count how many gravity direction. If it's more than one, then yes, we're going to do the calculation. And if we are not doing the calculation, let's get a ref, the first one, the zero, and then let's just set our gravity direction. So let's promote to local variable, final gravity direction, and we're going to set here if there's only one gravity points. Okay, now for the calculation. I will try to explain to you. I don't know if this will make sense. So let's say that we have two planets like here and then here. And then of course the point is going to be around here and around here. And for example, we have a player here. And let's say that this is gravity A and gravity B. We don't actually need to count the average between these 2 points and get the middle one and then gravity here. We actually just can get the first direction here, and then the second direction here. And for example, yeah, if the first direction is 1.1.1 and the second one is 1.1.1, and then how to actually get the middle is we can easily add this. So if it's like this, it's going to be resulting in 1.2.1. And then if it's got normalize, remember that we have normalize node in the end. It's going to be 0.5, and that's for x, and the middle one is going to be 1, and the z is going to be 0.5. So how do we do that? Let me show you. Let's get gravity direction again, and let's go for each loop like this. Since just think that, oh, we got so many things, let's just add them like this. So final gravity, yeah, just use an add. So each we found a gravity direction here, we're just going to add to this and we can reset the final gravity direction like that. So this should have our calculation here that I talked on the paint. And if it's completed, let's just put it out on the return node. Just like that. Maybe tidy this up a little bit. That should actually be it. Actually, so this calculation is actually a little bit fishy. So rather than risking the value is below 1, let's just multiply it by 12 times and then execute it. Oh, let's do another thing here. Is not empty. So we are going to only execute this if it's not empty. Hit compile and let me enlarge the planet a little bit more. So we got more planet radius, we got more gravity range. Let's go into our red planet. We can see that we landed safely on our red planet. Let's go to our green planet if we can. Whoop. Okay, we can. But we got help from this platform actually. Let's try to transition to our red planet again. No! Oh shit, we just jump and then drift very far from where we jump to where we at right now. I guess that is actually the reason why our moon can orbit around us for a very long time, for thousands of years, for eons. I'm already having fun, guys, actually. Let's search our planet again. Where is that red planet? Okay, that is our red planet. Let's try drift. No. Drift into our... Cannot. Still cannot. Can we jump? Cannot. Cannot. But I guess with this, our mechanic is actually complete. You know what? Let me cheat. Let me cheat so that... What is it? F8, yeah. Okay. Let me cheat so that our gravity range on the red planet, the orange planet, is actually bigger. Can we jump to there? Okay. Yeah, now we can. Okay, yeah, now we can. Can we jump to our green planet again? Whoa! Okay, now we are drifting into outer space. And with this, I say thank you. See you in the next video. The mechanic is fully working fine as intended. I guess in the next part, in the next video, I will make a jetpack so we can go around in space. And maybe let's zero out our gravity direction if we are no longer detecting any more planet gravity. And that's it. Don't forget to subscribe. Don't forget to like the video. Thank you for watching.